Welcome back everyone to Learning by Teaching. Today we're in dynamics and we're going to solve problem 12.114, okay? It says, the automobile has a speed of 80 feet per second at point A and acceleration having a magnitude of 10 feet per second squared. Acting in the direction shown, determine the radius of curvature of the path at point A and the tangential component of acceleration. Alright, so for this problem, what we have in here is that we have this car going around in this curvature, and as we've seen in this new chapter, our acceleration, in this case the one that I'm pointing out, it's our magnitude, can be split into two components, our tangential acceleration and our normal acceleration, okay? So let's start solving this problem by putting our givens down. So we got our velocity at A was given to be equal to 80 feet per second, and we're also given that the magnitude of this acceleration is equal to 10 feet per second squared. Now they're asking us to find the curvature, the radius of curvature, and also the tangential component of our acceleration. What we are given as well is that the magnitude of our acceleration is 30 degrees with respect to our tangential component, okay? So knowing this, what we can say is that our acceleration, our tangential acceleration, is going to be equal to our magnitude, which is 10, multiplied by the cosine of 30 degrees, okay? Now, if we put this into our calculator, we'll find out that our acceleration tangential will be 8.66 and then same unit feet per second squared. Okay, so this should be our first answer for this problem. And then they also want us to determine the radius of curvature. And we can find this radius of curvature because we know that our acceleration in the normal component is equal to our velocity divided by our radius, our curvature radius, okay? So all we need to do is solve for our curvature radius, and we will need to have, I apologize, it's our velocity square. So we will need our velocity square, and we will also need our normal component. And we can find this normal component because we are given this angle. So we also know that our normal component has to be our magnitude, which is 10, multiplied by the sine of 30 degrees. And if we put this into our calculator, this will give us a total of 5 feet per second squared. So now we can solve for our radius, and this should be equal to our velocity squared divided by our normal acceleration, okay? And if we put what those values are, where we know our velocity is equal to 80 feet per second, which is given by the problem. So we will have 80 squared divided by our acceleration that we just found, which is 5. Okay, so finally our answer, if we plug that into our calculator, we will find out that our radius is going to be 1,280 feet. Okay, and this should be our final answer for the curvature radius. Okay, if you guys like the video, please push the like button, subscribe, and I'll see you guys in the next one.